Problem 6-71. Solve the system of equations at right, and then check your solution in each equation. Be sure to keep your work well organized. That's very important with these because there's a lot of work involved, and it's very easy to get something mixed up and plug something into the wrong equations. So we have x minus 2y plus 3z equals 8, 2x plus y plus z equals 6, and x plus y plus 2z equals 12. First thing I need to do here is I need to decide which variables I want to end up eliminating first. So when I look at it here, and this one's kind of a toss-up. You could do whatever you wanted, really. But I do like the fact that I have one of my y's is negative here, and my other two y's are positive. And since the coefficient is 1, those ones are going to be easy to alter. So if I label these as A, B, and C, I'm going to go ahead and pair up A and B, and then I'm going to pair up A and C to eliminate my y's. So let's do that here. So my equation for A was x minus 2y plus 3z equals 8. And my equation B that I'm using is 2x plus y plus z equals 6. Now, before I write it over here, I'm going to go ahead and alter it up here just to save myself time so I don't have to keep rewriting these equations. So I'm going to take it here. I know that I'm going to need to have a positive 2y in the middle, so I'm going to multiply the entire equation here, both sides of it, by 2. So if you do this, just make sure you're careful that you don't leave something out. So 2 times 2x is going to give me a 4x. 2 times y gives me plus 2y. 2 times z gives me plus 2z. And that equals 12. So now it's set up to do elimination here. So I'm going to take it here. I'm going to eliminate my y's. I have negative 2y and positive 2y. So remember, that right there gives me a value of 0. So x plus 4x is going to give me 5x. 3z plus 2z gives me 5z. So I have 5x plus 5z equals 20. I'm going to go ahead and box in that equation so I don't lose track of it. That's an important one to have. Now let's go ahead here and let's do the same thing. I said I was going to do A and B, and then I was going to do A and C. So I'm just going to mark what I have here. You don't have to throw in, all this labeling, but sometimes it helps, just to help stay organized. So x minus 2y plus 3z equals 8 again. Now I look at C. I'm going to do the same thing with C that I did on the other problem. I'm going to do that kind of in green here to help you maybe see the difference. This one, I'm also going to need to turn my y into a 2y. So again, I'm going to multiply everything times 2. So 2 times x is going to give me 2x. 2 times y is going to give me plus 2y. And 2 times 2z is going to give me plus 4z. Now what does that equal? It equals 2 times 12, which is 24. Don't forget to multiply that side. That's a mistake that is made quite often. So once again, we want to make sure that we are canceling out the same variable that we canceled out the first time over here. So we have 3x. We have 3z plus 4z is 7z. And that equals 32. So right now, we've got 2 equations, each with the same 2 variables. So we're going to have to look at solving this system. When we do that, you could do, whatever method you'd like to use. You could do substitution or elimination. If you do elimination, it looks like you're going to have to alter both equations. If you do substitution, it looks like this one would be easy to get x or z by itself there because everything is divisible by 5. So it's your choice what you do. I'm an elimination guy. I like to do elimination, so that's what I'm going to continue doing. I'm going to go ahead and eliminate my x's. So I'm going to choose to eliminate x here. So in order to do that, I have a 3x and I have a 5x. So remember, I need to think of a number or a value that both 3x and 5x go into, and that would be 15x. So if I want to turn this into a 15x, I'm going to have to multiply this entire equation on both sides here by a 3. So don't scribble out your equation because you kind of still need it, but 3 times 5x is going to give me 15x. 3 times 5z is going to give me 15z. And that should equal 60 at this point. Now, my other x here, I'm going to have it end up equaling negative 15. So in order to get that, think about what do you have to multiply 3 by to get negative 15x. We're going to end up needing to multiply by a negative 5. So negative 5 times 3x is going to give me negative 15x. Negative 5 times 7z gives me a negative 35z. And then on the other side here, negative 5 times 32. Well, 5 times 30 is 150, and 5 times 2 is 10. So we're going to end up with negative 160. Well, let's continue on here. So as we look to eliminate these, or eliminate our x values here, we're left with 15z and negative 35z. When we add them together, 15 of the positives are going to cancel out 15 of the negatives, leaving us with negative 20z. And then 60 positives cancel out 60 of the negatives here. That should end up equaling negative 100. Finish solving it here, and we're going to end up with a value of what, 5 is what z is going to equal. So right now z equals 5. Now to end up with our other values, we're going to have to be smart about where we plug in this 5. We don't want to plug it back into the original equations because we still have too many variables up there. So use one of your 2 boxed equations. I'm going to plug in 5 for z in this equation. So I'm going to find x. And you may want to label where you're doing it at, so that way if you keep your work organized, if you make a mistake, you can figure out what you did by retracing your steps. So I'm going to do 5x plus 5 times 5 equals 20. 5 times 5 is 25. Let's bring down what we've already got. 5x plus 25 equals 20. Subtract our 25. So we have 5x is equal to negative 5, which means that x is going to end up equaling negative 1. So we know that z is 5. We know that x equals negative 1. And the next thing we can do here then is figure out what our value of y is. So to do that, let's look at one of our original equations. So here we go. Let's look at our x minus 2y. We're going to say x minus 2y. I'm just going to recopy it down here so I can keep track. Equals 8. So we're going to find y. I'm going to make it so I can scroll down a little bit there. If I know z is 5, I'm going to plug it in for z, and I know x is negative 1, so I'm going to plug it in for x. So I have negative 1 minus 2y plus 3 times 5 equals 8. Well, that's going to give us 15. And we have negative 1 minus 2y plus 15 equals 8. Combine our like terms. A negative 1 and positive 15 is going to give us 14. So negative 2y plus 14 equals 8. Do not forget this negative. I'm almost willing to bet $100 here that somebody in one of my classes is going to lose track of this negative here and going to get the wrong answer because of it. I can't gamble on school stuff though, but it's bound to happen. So don't let it be you. Subtract our 14, we've got negative 6 equals negative 2y. Divide by negative 2, and we get y equals 3. So our solution, the intersection point of these three planes here, we're looking at the point negative 1. That's our x. Our y is 3. Make sure you put them in the correct order. And z is 5. So I'm going to scroll up here. Now let's look at different ways for checking it here. They want us to take them. We can plug them in. That's easy to do. We can go ahead and do that. So we used our first equation to solve it, so let's just plug them into the second equations. So let's just go ahead and do our check here. Let's do it over here. Let's check this middle one in red. So this is our check. This is kind of our check area. Just because we're on a computer screen here and we kind of have to squeeze it all in. Oh, I don't know what I just did there. That's awesome. But, oh well, hopefully it doesn't affect us too much. I have no idea what happened. All right, so this is our check. We're going to take it here. Let's plug in negative 1 for x. So we're going to say 2 times negative 1 plus our y, which is 3, plus z, which is 5. And that should equal 6. 2 times negative 1 is negative 2, plus 3, plus 5. Negative 2 plus 3 is positive 1, plus 5 is 6. We get 6 equals 6. That is correct. And then let's do the second one here in green, x plus y plus 2z. So negative 1 plus 3 plus 2 times 5 should equal 12. So negative 1 plus 3 is 2. 2 times 5 is 10. So 10 plus 2 is 12. Which means we are correct. So we've checked it there. This is problem 6-71. We're just working on solving systems of equations with 3 unknowns here. If you have questions, make sure you ask your teacher. Thanks for watching.